blue hole is basically just a massive sinkhole in the ocean, and they can take over 100,000 years to form. Blue holes are often hundreds of feet deep, which gives them that deep blue color in contrast to the shallower water around them.
Somewhere off the coast of Belize, in the middle of the Caribbean Sea, there is a giant dark circle in the ocean, so perfectly round and so massive that you can see it from space. For a long time, nobody knew what was at the bottom. Divers tried and turned back, and scientists made guesses. Then, in December 2018, a team finally went all the way down. And what they found down there was not what anyone expected, not even close. The eye in the sea. If you have ever seen a photo of the Great Blue Hole from above, you already know it looks like something out of a science fiction movie. It is a near-perfect circle of deep, dark blue water sitting right in the middle of a shallow turquoise reef. And the contrast between the two colors is so sharp, so clean, that early astronauts who spotted it from orbit actually photographed it and asked what they were looking at. The numbers alone are hard to wrap your head around. The hole is about 1,000 feet across, and it drops straight down to 407 feet deep. To give you a sense of that, if you stood the Statue of Liberty at the bottom of this hole, the torch would still be over 200 feet below the surface. It is not a shallow dip or a gradual slope. The walls go almost completely vertical, straight down into the dark, like someone punched a hole through the ocean floor with a giant drill. And that is not far from what actually happened. The Great Blue Hole is what scientists call a blue hole, which is a specific type of underwater sinkhole. These form in areas where the rock below the seabed is limestone. Limestone is a soft rock that rainwater can slowly eat away over thousands of years, carving out hollow spaces underground. The Great Blue Hole started out as one of those hollow spaces, except it was not underwater when it formed. It was a dry cave, sitting above sea level on land. Scientists who have studied the stalactites inside the hole have found through chemical testing that the cave was already forming up to 153,000 years ago. So for tens of thousands of years, this was a cave that sat above the water, growing bigger and bigger as rainwater dissolved the rock from the inside. And then, about 10,000 years ago, everything changed. At the end of the last ice age, the enormous ice sheets that covered much of the planet began to melt. All of that water flowed into the world's oceans, and sea levels rose dramatically. Richard Branson, one of the people who later dived into the hole, described seeing the evidence of this firsthand when he was inside the submarine. He said that at around 300 feet down, you could actually see the point in the rock where dry land ended and the ocean began. The sea rose, the cave flooded, the ceiling eventually collapsed, and the result was the dark, perfect circle we can see from space today. It sits right at the center of Lighthouse Reef, a small coral atoll about 43 miles off the coast of Belize City. The reef around the rim of the hole is shallow and bright, full of life. But the hole itself drops away into something altogether different. And for most of modern history, nobody had any idea what was down there past a certain depth. But that soon changed. The man who made it famous, and the name that stuck. The Great Blue Hole might have stayed a local curiosity known only to Belizean fishermen if it were not for one of the most famous explorers who ever lived. In 1971, French oceanographer Jacques Cousteau brought his legendary research vessel, the Calypso, out to Lighthouse Reef and made the hole famous by documenting it for his television series, The Undersea World of Jacques Cousteau. He called it one of the top 5 dive sites in the entire world, and that endorsement sent divers from every corner of the planet heading to Belize. What is interesting, though, is that Cousteau did not actually name it. The name The Great Blue Hole came from a British diver and author named Ned Middleton, who used it in his 1988 book, 10 Years Underwater. Middleton's reasoning was straightforward. If Australia could have the Great Barrier Reef as its famous natural landmark, then Belize deserved the Great Blue Hole. The name stuck immediately and has been used ever since. What Cousteau's 1971 expedition did confirm was the hole's origin story. His team collected stalactite samples from inside the cave walls and confirmed that the hole had indeed formed above sea level, as a dry limestone cave, before being swallowed by the rising ocean. They also mapped out a series of ledges inside the hole at different depths, left behind at each stage as the sea level rose in multiple phases over thousands of years. This was genuinely new scientific information at the time, and it gave researchers the first real structural picture of what the hole looked like from the inside. But here is the thing. Cousteau's team only documented the upper sections of the hole, the parts that recreational divers could reasonably reach. The standard limit for recreational scuba diving is around 130 feet, and even technical divers using specialized equipment rarely went below 200 feet inside the hole. Everything below that, the lower third of this 407-foot structure, remained a mystery. The 1997 expedition conducted by the Cambrian Foundation managed to collect small sediment core samples from the very bottom, reaching depths of over 400 feet using advanced technical diving. But there was no full interior mapping, no camera coverage of the walls, no systematic documentation of what was down there. And so for decades after Cousteau put it on the map, the Great Blue Hole sat there, attracting thousands of divers every year to its upper walls and spectacular stalactites, while everything below the sunlight stayed completely unknown. That was the situation going into late 2018, when somebody finally decided to go all the way down and get the whole picture. The mission nobody had done before. The plan for the December 2018 expedition was straightforward on paper, but enormous in practice. The goal was to do something that had never been done before, and that was to create a full, complete, three-dimensional map of the entire interior of the Great Blue Hole, from the surface all the way to the floor, using submarines. The team that came together for this was led by Aquatica Submarines, a Canadian company that builds and operates research submersibles. Their chief pilot and operations manager was a woman named Erica Bergman, a National Geographic explorer and oceanographer who would end up being the key voice describing what they found. Joining her were two very famous names. Sir Richard Branson, the British billionaire and founder of the Virgin Group, provided funding and his own presence on the dives. And Fabien Cousteau, the grandson of Jacques Cousteau, brought both diving expertise and a deeply personal connection to the site, given his grandfather's history with it. The expedition ran from November 27th to December 13th, 2018, and the team conducted 22 dives in total. They used two manned Aquatica submarines, including a model called the Stingray 500. On December 2nd, one of those dives was broadcast live on the Discovery Channel, which meant millions of viewers around the world were watching in real time as the submarine descended into the hole. The technology they brought was seriously high-end. Surface and submarine-mounted sonar systems from Norwegian company Kongsberg were used to map the internal geometry of the hole with high resolution. Sonar expert Mark Atherton operated the equipment from the research vessel Brooks McCall at the surface, building up a complete sonar picture of the hole layer by layer. The submarines carried high-definition cameras and instruments to measure water chemistry, temperature, and bacterial activity at every depth. The idea was to come back with not just footage, but a full scientific data set that could be shared with the Belize government and the global research community. And they did. What they came back with, they also included some things nobody had put in the mission brief. Going down. The descent into the Great Blue Hole starts beautifully. In the upper sections, the walls are alive. Caribbean reef sharks patrol the edges. Turtles drift past. The walls are covered in coral formations and enormous stalactites, some of them several feet long, hanging from cave overhangs in the walls. During the 2018 expedition, the team discovered stalactites that had never been documented before, found right at the very deepest reaches of the hole near the 400-foot mark. These formations are direct physical proof that this place was once a dry cave, sitting in open air, because stalactites only form when mineral-rich water drips through rock in an above-ground environment. They cannot form underwater. As the submarine goes deeper, the light begins to thin. The walls are still visible, but the darkness is gathering. At around 130 feet, where recreational divers turn back, the hole is still impressive. But the submarine keeps going, past 200 feet, past 250 feet, and then, at around 290 feet below the surface, something changes. The water changes color and texture. A thick, hazy layer appears, stretched across the entire width of the hole. It looks like a translucent fog sitting in the water. This is the hydrogen sulfide layer, and it is one of the most significant features inside the Great Blue Hole. Hydrogen sulfide is a toxic gas produced when bacteria break down organic material in water that has no oxygen. It sits as a dissolved layer in the water, and it separates the oxygen-rich water above from the completely oxygen-free water below. Erica Bergman described it as a chemical barrier more absolute than any wall. She explained it this way: everything that ever fell into the hole decomposed normally as it passed through the upper oxygen-rich water, using up all the available oxygen in the process. Once all the oxygen below 290 feet was consumed, anything that fell past that point from then on had nothing to decompose it. No oxygen means no aerobic bacteria. No aerobic bacteria means almost no decay. Below 290 feet, the Great Blue Hole is a preservation chamber. And when the submarine finally crossed through that hazy hydrogen sulfide layer and the lights cut through the total darkness below, what they saw on the floor of the hole was something nobody had been prepared for. The graveyard at the bottom. The floor of the Great Blue Hole is covered in things that fell in and never resurfaced. The most numerous are conch shells, thousands of them, spread across the bottom in every direction. Bergman described in a blog post written after the expedition what the scene looked like. The conchs had apparently wandered too close to the edge of the hole at the rim and tumbled in, and she could see, in the sediment, the tracks they had made trying to crawl back up the slope, little lines in the sand showing where each one had tried to escape, followed by a long slide mark where it had lost the battle and slipped back down into the hydrogen sulfide layer and suffocated. Thousands of small tragedies perfectly recorded in the sediment, going back who knows how many years. Along with the conch shells were hermit crabs and small fish, all gone through the same process. Old scientific equipment from past research expeditions was also sitting on the floor, perfectly preserved. And there was also modern rubbish. Branson wrote about this himself in a post following the dive. He found plastic bottles sitting on the bottom, and he described it as one of the starkest reminders he had ever seen of the damage being done to the world's oceans. A 2-liter bottle had made its way down to the bottom of a 400-foot sinkhole, miles from the coast, and it would stay there preserved in that airless environment for an extremely long time. The team also found a lost GoPro camera with footage from someone's dive trip still intact on it. But then there were the bodies. Bergman has said in multiple interviews that 3 people are known to have gone missing inside the Great Blue Hole over the years. During the 2018 expedition, the team found what they believed to be the remains of 2 of those 3 people, lying on the floor of the hole in the oxygen-free dark below the hydrogen sulfide layer. Because there is no oxygen down there, and essentially no bacterial decay, the remains had been preserved in the darkness for years. Bergman described the decision the team made in an interview with Business Insider. They found the resting place of those people. They very respectfully let the Belize government know where they were, and everyone agreed that no recovery attempt would be made. It was dark and peaceful down there, she said, and they decided to let them stay. What the walls and the floor are telling us. The full 3-dimensional sonar map that came out of the 2018 expedition was a genuine scientific first. Nothing like it had existed before. The map showed the complete internal geometry of the hole, every ledge, cave opening in the walls, and every slope and contour of the floor. It confirmed the multi-stage flooding history that Cousteau's team had suggested in 1971, with ledges at several different depths marking each phase of the rising sea. But the map also revealed something about the floor itself that turned out to be scientifically very important. The bottom of the Great Blue Hole has been collecting sediment for a very long time. Particles from the reef, surrounding ocean, organisms that died above and sank down, and from organic material swept in during storms, all of it has been slowly settling to the floor and building up in layers over thousands of years. Because the anoxic environment at the bottom prevents almost all decay and biological disturbance, those layers sit undisturbed, stacked in perfect order, oldest at the bottom and youngest at the top. Scientists describe this kind of sediment deposit as a sediment trap, and the Great Blue Hole is one of the best natural examples of one on the planet. The bowl shape and the isolated chemistry mean that whatever falls in stays in and stays in order. In the summer of 2022, a team of scientists from Goethe University Frankfurt brought a drilling platform out to the hole and extracted a 30-meter sediment core from the floor, which is a cylindrical sample that goes straight down through all those layers like a timeline. That core covered 5,700 years of history in a single tube of mud. The detail inside that core was extraordinary. The scientists identified 574 individual storm event layers, meaning they could see the physical signature of 574 separate hurricanes and major tropical storms that hit the region over nearly 6,000 years. Each storm left a distinct layer of coarser particles swept in from the reef edge. This is a climate record that goes back far beyond anything written or measured by instruments, which only cover about 175 years of Caribbean weather history. And the sediment core told the researchers something troubling about where things are heading. Storm activity in the southwestern Caribbean has been rising steadily over the past 5,700 years, and the rate of increase has jumped sharply in the last 2 decades. More storms hitting this region in recent years than at any comparable period in the entire 6,000-year record. The hole has been keeping score all along, and the score is getting worse. But the sediment was also hiding something else, something from much further back in the record, something that connected this underwater hole in Belize to one of the greatest unsolved mysteries in all of human history: the mud that changed history. Before the 2022 Goethe University expedition, a scientist named Andre Droxler from Rice University in Texas had already been doing research with sediment samples from in and around the Great Blue Hole for several years. Droxler's team drilled their own sediment cores from the hole and from 2 other nearby sites, the Rhomboid Reef and the Belize Central Shelf Lagoon. They then cross-checked their findings across all 3 locations to make sure what they were seeing was real and not just a local quirk of one spot. What they were looking for was a chemical signal in the sediment that could tell them about rainfall over time. The signal they used was the ratio of titanium to aluminium in each layer. Here is the logic behind that. The rocks in the volcanic mountains of the region contain titanium. When heavy rains fall, they break down those rocks and wash the titanium into rivers, which carry it out to the coast and eventually into the sediment of the Blue Hole. So layers with high titanium relative to aluminium mean there was a lot of rainfall when that layer was laid down. Layers where titanium drops off sharply mean the rains had slowed or stopped. When Droxler's team ran the numbers, they found something that made them look twice. The titanium levels in the sediment layers covering the period from around 800 AD to 1000 AD were dramatically lower than in the layers before and after. Not just a little lower, significantly lower. The signal was strong enough, and it matched well enough across all three sampling locations that the conclusion was hard to avoid. The region experienced a severe and prolonged drought during those 2 centuries, a drought far beyond the normal dry season patterns. And then they found it again. Another drop in titanium levels in the layers covering 1000 AD to 1100 AD. A second drought, following closely after the first. Droxler told Live Science at the time that when you have major droughts, you start to get famines and unrest. That is a careful, measured way of describing what those 2 drought windows may have meant for the people who were living in this part of the world at that exact time. Because the people living in this region during those centuries were among the most remarkable civilization builders the Western Hemisphere had ever seen. The civilization the sediment remembers. Between roughly 250 AD and 900 AD, the Maya built one of the most remarkable civilizations the Western Hemisphere has ever seen. Their city-states spread across what is now southern Mexico, Guatemala, Belize, and Honduras, and the cities themselves were extraordinary. Tikal, Palenque, Copan, and Chichen Itza had massive stone pyramids, royal palaces, ball courts, and astronomical observatories that were built with a level of precision that still impresses engineers today. The Maya developed one of the only fully functional writing systems ever created independently in the Americas. Their mathematics included the concept of zero. Their astronomical calendars tracked the movements of Venus and could predict solar eclipses with real accuracy. At their peak, their total population may have been somewhere around 10 million people spread across hundreds of cities and towns. And then, starting around 800 AD, it all began to fall apart. City after city across the southern lowlands were dismantled. New monuments stopped being built. Populations scattered. The great classic Maya centers in what is now Guatemala and Belize were gradually abandoned, and the jungle moved back in fast. Within a few generations, some of the greatest cities in the ancient Americas were empty shells being swallowed by trees. And for over a century, historians and archaeologists have been arguing about why. The theories are numerous, and none of them has ever fully convinced everyone. Warfare between city-states is documented, but it had been happening for centuries without triggering total collapse. Overpopulation and deforestation are plausible, but hard to time precisely against the collapse. Disease, trade network breakdowns, political fragmentation, and even large-scale peasant revolts against the ruling class have all been put forward at various points. Each one has some evidence behind it, and each one has problems too. The factor that keeps coming up in the most recent scientific research, and the one the Great Blue Hole sediment speaks to most directly, is water. The Maya heartland in the southern lowlands had very few rivers and almost no permanent lakes. The entire food system that kept 10 million people alive ran on seasonal rainfall. The Maya built reservoirs and terracing systems to collect and hold water, because if the rain failed badly enough, for long enough, across a wide enough area, there was simply no backup plan. The crops would fail, the food would run out, and the social structures holding those enormous city-states together would come under pressure they were not built to survive. This is where Andre Droxler's sediment work becomes genuinely significant. His team at Rice University analyzed the ratio of titanium to aluminium in the sediment layers from the Great Blue Hole and 2 nearby sites to reconstruct rainfall patterns going back through the centuries. The logic is quite straightforward. When the rains are heavy, they break down volcanic rocks in the surrounding mountains and carry titanium down through rivers to the coast, where it settles into the sediment. When the rains stop, the titanium input drops sharply. So each layer in the sediment core is carrying a rainfall reading for the period when it was laid down. What those readings showed was 2 separate drought signals. The first covered roughly 800 AD to 900 AD. The second covered roughly 1000 AD to 1100 AD. Both were severe enough to show up clearly in the titanium record, and both coincided with striking precision with the two main phases of Maya collapse: two droughts and what they left behind. The first drought lines up almost exactly with the abandonment of the great classic Maya cities in the southern lowlands. Tikal, Palenque, and dozens of others went quiet during this period. And Droxler's team found that during this same stretch of time, the region was also hit by dramatically fewer hurricanes than normal. On average, 5 or 6 major tropical storms would typically strike the southwestern Caribbean in any given 20-year period. But during those 2 centuries, only 1 or 2 did. Fewer storms might sound like a good thing for crops, but it is actually another symptom of the same underlying climate problem. Both the drop in rainfall and the drop in storm activity were pointing to the same cause: a large-scale shift in the weather patterns of the region that cut off the moisture the Maya depended on to grow food. And though the cities emptied, the Maya people did not vanish, but adapted. A significant number of communities moved north into the Yucatan Peninsula and rebuilt. Chichen Itza grew into a major new center of power through the 10th and 11th centuries. The northern Maya survived, and for a while, they even thrived. Then the second drought arrived, and it was the same signature in the sediment: another prolonged dry period. And this time, Chichen Itza itself went into decline. The last significant center of classic and post-classic Maya power did not survive the second hit. Droxler has been careful to say that the sediment record does not close the debate on its own. He said that it is plausible that these droughts sparked famines and unrest, not that they single-handedly destroyed a civilization. The Maya collapse was almost certainly a combination of pressures, and drought was probably one of several things that all landed at once. But the sediment record from the Great Blue Hole, taken together with matching findings from other research sites in the region, builds a very strong case that prolonged water stress was at the center of it. And that evidence was sitting 400 feet underwater, in a flooded cave off the coast of Belize, for over 1,000 years before anyone thought to go get it. That is the thing about the Great Blue Hole that is quite so amazing. It was not just a spectacular dive site, but a record keeper. A cave that flooded 10,000 years ago and spent the next 10,000 years collecting evidence that no one knew it had. Evidence of storms, droughts, of people who came looking and never came back. And now evidence that may help explain the end of one of the greatest civilizations in the history of the Americas. And the Great Blue Hole is not the only blue hole that has yielded astonishing discoveries. In Chetumal Bay, near the Mexico-Belize border, sits Tamja, a Mayan phrase meaning deep water, which currently holds the record as the deepest known blue hole on Earth, at over 1,380 feet. But even that is not the actual bottom. When scientists measured it in 2023, their instruments ran out of cable before they reached the floor. Nobody has ever seen the bottom of Tamja. Instruments also detected an abrupt change in water temperature and saltiness partway down, suggesting the hole may connect to the vast network of flooded underground caves called cenotes that stretches for hundreds of miles beneath the Yucatan Peninsula. If that is true, then Tamja could be a door into a system that nobody has ever fully mapped. Additionally, there is also the Dragon Hole in the South China Sea, first measured in 2016 at around 987 feet deep. Scientists using underwater robots found 1,730 distinct types of viruses living in its oxygen-free lower waters, the majority of them species never recorded anywhere in the world before. These viruses have been evolving in complete isolation for an estimated 14,000 years. Most of them are bacteriophages, meaning they attack bacteria and not animals. But the deepest layers of the hole contain viral types that researchers have not been able to match to any known group at all. 14,000 years of evolution with no contact with the outside world produces things that are genuinely new. Blue holes are found all over the world, wherever limestone meets water. Most of them have never been explored. Most of their floors have never been seen. Most of what they have been collecting and preserving over the centuries has never been touched. The Great Blue Hole gave up a graveyard, a climate record, and a piece of one of history's greatest mysteries. But the others are still waiting to be explored. So here is what we want to know from you. If divers finally reached the bottom of the Great Blue Hole and found all of that, what do you think is waiting at the bottom of Tom Jah and other blue holes we're yet to extensively explore? Leave your answers in the comments below. Don't forget to like the video and subscribe to the channel. Thank you for watching, and if you enjoy this video, please click on the next one on your screen.